Washington State University. Go Cougs!
Hello everyone. In this video we're going to cover Lesson 8, our last lesson in the Working with Activity and Health Data module. In the previous lesson we discussed time series, date time index, and resampling. We're going to continue our time series conversation in this video by discussing how we can visualize time series data. So I have some code here that is going to read in the same data set we were working with in the last example. So I'll go ahead and read it in with a date time index. Looks like it was loaded good. So let's start visualizing the data. I first want to visualize the data one day at a time. And the one day I want to look at is the first day. And while we could look at all of the activities for the first day, just to save on time and space, let's just look at the sleep activity. So now I need to figure out what is the date for the first day in the data set. So I'm going to call a variable day1, and it's going to be a string, a return value from df.index of 0. So just go ahead and grab the first timestamp in our date time index and get a string representation of it where I'm only interested in the year, the month, and the day. And let's go ahead and print this out. So we see the first date in our time series is July 18th, 2013. Next, let's get the sleep hourly data for this particular day. I'll call it day1 ser, gets df.ix day1, and we'll index into the activity column. And we'll print out day1 ser. And there it is, hourly by hourly probabilities for sleep. Now we're ready to prepare to plot this data. I'd like to use a bar plot. I think it's really easy to see the probabilities with a bar plot. So I'm going to need some x values, which I'm going to use simply integers 0 to 23. But I'm going to get my 23 from the length of our day1 ser. So the number of rows or number of items in our day1 series, which is 24, so that'll give us hours 0 through 23. Next, I'm going to get references to the figure and axes for a new subplot. And now I'm ready to go ahead and plot. So plot.bar, xvals, and day1 ser. Do plot.show to get rid of that return value, and there it is. Now we can add some bells and whistles to this plot, such as a title, an X label, a Y label, and then changing these X ticks to be hourly and adding hourly labels. So let's go ahead and do that. I'll do it for this first example, but for the rest of them I'll have to copy and paste some code due to time. So let's set plot.xlabel to be hour and plot.ylabel to be probability. And let's set the title of this plot to be day1. That's our string representation of the date, plus activity, which is sleep in this case. And let's check it out. Looking better. Now let's go ahead and set the tick locations to be hourly. So I'll have X tick locks bnp.arrange len day1 ser. This is actually going to be the same as xvals, but I'll have the label be different just so it's clear. And I'm going to use my axis object to set the xtick location to xtick locks. And now we have 0 through 23 as all of our tick locations. So instead of 0 through 23, now let's add a really nice hour, minute, and AM, PM label to each one of these tick locations. So let's call it XTick Labs for XTick labels. I'll use a list comprehension in order to construct this list, and I'll do a string representation of the timestamp, stir f time, with the hour, %I, the minute, and whether it's AM or PM for the timestamp in day1 ser dot index. And then I can go ahead and say ax.set xtick labels and setting them to xtick labs. And I'm going to set a 45-degree rotation and a right alignment, just so that it's easier to see. And there is our plot. That looks much more readable than before. We have labels and we have ticks for every single bar. Now, let's take a look at how we can visualize our entire data set, which has multiple days in it, 7 days to be exact. So what I want to do is now I'm going to grab all of the sleep data. So all ser is df sub activity, the activity column. My xvals are going to be np.arange, 0 to the length of all ser. And I'm ready to plot my bar chart, xvals and all ser. So here's my plot here. We can see 7 clusters of bars that are fairly tightly spaced and then separated by a lot of white space. So I'm not incredibly happy with this plot. It doesn't really give us very much of an indication of how the days compare because the data is so tight and then so sparse. So I want to look at another way that we can visualize multiple days of data. But before I do, I'm going to add some bells and whistles to this plot, but I'm going to do so simply by pasting in some code that's going to add all those labels that we took the time to do earlier, just so that we can move a little bit faster. So what I'd like to do is I'd like to take each one of these days and plot them individually like we did our first day, but stack these 7 plots on top of each other so that all hours are aligned. In order to do this, we're going to have to look at an example of how we can have multiple axes on the same figure. So here I have some example code. I'll go ahead and run it, and then I'll explain it, where we're using the subplot command to specify the number of rows, the number of columns, and the index of the current axes we want to plot on. So this says we have a 2 by 2 grid. Here's our 2 by 2 grid. And this first plot is going to be at index position 1, which is here. And then I simply plot some squares in color blue. So we see that here. And then index position 2 will be green. We see that here. Index position 3 will be red. We see that here. Index position 4 will be black. We see that here. So this is how we're going to specify multiple axes on the same figure. But I don't want ours to be a grid. I want ours to be 7 plots all stacked on top of each other in one big column. So let's take a look at how we can do this. So first things first, let's have a variable called numDays, which is going to represent the number of days in our data set. I'm going to use a variable called dateLabels that I copy and pasted in earlier. So this is 7. And while I'm at it, let me show you what dateLabels looks like. It's just a string representation of each date in our data set. Next, I'm going to create the new axes and for our figure. So plot.subplots, but this time I'm going to specify that there are supposed to be 7 subplots. And I'm going to set share x to true and share y to true as well. Meaning these are all 7 of these plots are going to share the same x-axis and the same y-axis. The x-axis will be 24 hours in a day, and the y-axis will be probability of 0 to 1. Then I'll get my x values, which will be the same as before. The length of, let's say, day 1 ser. And here are our 7 empty plots, all stacked on top of each other. So now we're going to go through for I, date in enumerate date labels. So we're going to get an index position and a string label for each one of our dates. We're going to select from our axes, which is a list now, the current axes associated with index position I. We're going to get the sleep data in the form of a series from our data frame by selecting this date and our sleep activity. We'll go ahead and plot this, xvals and dates there. And let's set the y label for this particular axis to be the date. And now we have our sleep data for each day nicely stacked on top, and we can easily now see what hours of the day they're most likely to be sleeping during this week. I'm going to go ahead and copy in some code that is going to finish this plot to make it nice and pretty, just to save on time. So you can see the final output, mostly just adding in labels, changing our x-axis to, our y-axis to go on every other side so that our labels don't overlap, and adding in our same midnight to 11 p.m. labels that we had from our first plot. The one last thing I want to show you is another visualization we can do quite easily is to aggregate all of our days by taking the average for all 7 days and collapsing it down into one day. So essentially what we're going to do is for each hour, day 1, day 2, day 3, day 4, day 5, day 6, day 7, we're going to average it, and that's going to be our aggregated day first hour. And we're going to do this for all 24 hours. So let's take a look at how we can do this. So let's get all of the sleep data. We'll go ahead and compute the mean for each hour of the day by grouping our data by the hour. And we'll take the mean, and then we're ready to plot mean.ser index, or mean.ser.index, and mean.ser, and we'll show this plot. So here's what the probability of sleep looks like for the entire week.